Good afternoon, everybody, or good morning, depending upon your location. Welcome to the Energy Management Association webinar, Essential Techniques and Calculations for Energy Managers and Commissioning Authorities. My name is Bob Knoedler. I'm with the board of EMA, and we have a lot of people registered for today's webinar, and many of you are still in the process of signing on, so we'll get started momentarily. This is a great time for me to recognize today's sponsor, PointGuard, who made this free 2-hour training event possible. We'll be back in about 2 minutes.
The PointGuard platform is facility management software. It's software that harnesses a massive amount of sensor data that's increased over 400% in modern buildings and brings it into precise, actionable information for the facility teams that run those buildings.
One of the things that we really try to focus on here at PointGuard is a play-to-win mentality that we translate into our daily lives and our daily work. We try to be as customer-focused as possible in our philosophy and translate the work that we do into a valuable product for our customers.
PointGuard is established to provide transparency to the built environment. And in so doing, we can help facility teams improve the performance of their buildings, help building owners make smarter and better improvements to their buildings, and help occupants have a better experience in their buildings. Facility and property management teams have less time than ever before and more complicated buildings than ever before. Our platform allows them at scale to manage very complicated buildings in a minimum amount of time.
We've battle tested it. We've used it on millions of square feet of real buildings with real facility engineers, real owners, real people in those buildings, and we've learned a lot of lessons along the way. So we've improved our platform to address those lessons, which makes it a lot more helpful now for people that use our platform.
Well, I'm passionate about PointGuard because of the people that come here and the commitment that they have to our company, and also the positive impact we're making on the built environment. The built environment today is the highest polluting asset class in the world that's unregulated. And if you don't have good commercial products that drive profit, that performance and that environment and that waste will never be controlled. You're not only going to see better productivity, better tenant retention, lower capital costs, predictive and better maintenance, and significant reduction in energy costs.
Okay, again, thank you to PointGuard, our today's sponsor, and we're ready to go. Again, my name is Bob Knoedler. I'm with EMA, and what we're going to do today, we've basically created a condensed version of our energy management professional workshop that we conduct. It's about a day-and-a-half workshop. It goes into more detail, obviously, than this condensed webinar today. But this kind of gives you an overview of it. We're going to talk a little bit about energy management, talk a little bit about the process, from planning, working through establishing baselines and benchmarks, analyzing utility invoices, energy auditing, and then all the way through to persistence of savings. One of the things we do in our workshop is go through a lot of problems. In fact, candidates are given a whole large set of over 50 problems before we even start, and then we work through those as well as go into a lot more detail than you'll see today. Again, our learning objectives, we want to talk a little bit about the importance of energy management along with its synergy with commissioning, the key qualifications and services that an energy manager or energy management professional would provide, and those include things like energy planning, energy auditing, and then working through the implementation of various measures and that measurement and verification and savings persistence. And then finally talk a little bit about why technical certificates such as the energy management professional that we provide are very important. So with that, we'll start out. And one of the things, again, why is energy important? Why energy? You hear a lot about it today. Well, again, this is only a few months old. Energy demand skyrockets. Last year, energy demand globally grew by 2.3%. And that's really the fastest pace this decade. As you can see here by the bullets, 45% was accommodated by natural gas. About 70% of that growth was accommodated by fossil fuels, while at the same time, both wind and solar grew at double digits, solar by 31%. But last year, the U.S. generated 4.18 trillion kilowatt hours of electricity. And globally, the electricity demand grew by more than 4% to 23,000 terawatt hours, which is trillion watt hours. So that rapid growth pushes electricity to really a 20% share in the final consumption of energy. I think anybody today would not argue that electricity is probably the primary source when you're looking at buildings, when you're looking at, again, cell phones, when data centers and all of the computing that's going on. Electricity and the demand for it, the globally, the appetite is really insatiable at that point. Renewables are a major contributor. They continue to grow, and almost half of the electrical demand last year was accommodated by renewable energy. The other big increase is 1/5 of last year's increase for global demand was based upon heating and cooling. We're seeing a lot more of the third world countries come in as far as space conditioning goes. And then, and this is really important, that China, the United States, and India accounted for almost 70% of the rise in energy demand. And you would almost expect that, again, based upon their populations and based upon where they are economically on the world stage. So talking a little bit about energy managers, what they do and what their qualifications are. You know, obviously one of the things they have to be able to do is to analyze their clients' utility bills, evaluate them, and be able to both baseline and benchmark the performance of their buildings or facilities. They also have to have a real good understanding and expertise in both mechanical, electrical building systems and the associated controls with such. They get involved heavily in both energy and water auditing, identifying opportunities for measures, and then really evaluating or assessing those opportunities and those measures. They have to be able to perform calculations and conversions, and that's one of the things that we stress in our workshop, related to both savings of consumption and then payback, life cycle costs, and again, depending upon what they're trying to achieve and what their goals are for their particular client or customer. And then finally, you know, various energy conservation strategies, both on the control side, and then really being aware and alert of the new renewable energy conversions and control and systems that are out there today. Their services and deliverables, here's a list of some of them. I mentioned already the audits. They also may be involved in facility condition assessments, retro commissioning on existing buildings, other various facility studies. They often get involved with the sustainability or resiliency consulting with the various customers or clients that they serve. Sometimes they get involved in energy modeling or reviewing energy models and using those somewhat for measurement verification and, again, verifying the performance of their systems. They may work with an energy service company to, you know, ensure that the guaranteed savings are being provided. And then all the way through, they may even be involved in the procurement of contracts. They may be involved in helping to implement the various measures with the facility manager or with their client's corporate group. There's a number of applicable codes and standards that apply. I've just listed a few of them here. When you get into energy guidelines, energy codes, standards, ordinances, so on and so forth, this is a list of some of the pertinent ones. Many of them relate to ASHRAE. 90.1 is really the benchmark, and it's updated every 3 years. the energy standard for buildings. It's adopted by most states with respect to their energy codes. You also see some of the others here for energy audits. We'll talk about those as we go through, and some of the other guidelines, but there's a bigger group than this. All this information is available out on the internet. One of the specific sites I want to send you to is, again, this Building Codes Assistance Project. And you can see at the bottom of the screen, you can kind of see the internet address, the link for that. And what this is a group that updates and maintains the current energy code adoption in the various states around the country. For example, North Carolina, which is where I'm located, just adopted their latest version of their building code, 2018, which was adopted and made effective January 1st of this year. And by reference, it adopts the 2015 International Energy Conservation Code. Well, again, if you're working throughout the United States, you're working in various jurisdictions, you're working for different clients, this is a great resource to go to find out where they are with respect to their current requirements. So we'll start out talking a little bit about energy planning, and we can't go into a lot of detail, but I wanted to kind of give you an overview of what a strategic energy plan would look like. And this is kind of a breakdown. There's many corporations, institutionals, clients, even some government entities that are really mandated to have a strategic energy plan. They've got to basically take a look where they are today, what their baseline is, what their capital plans are, what their projections are as far as growth, and then take a look in terms of what their goals are. Are they trying to reduce consumption by a certain percentage over a period of years? Are they trying to become net zero within a certain finite period? You hear that a lot today from different municipalities, different states, different organizations that are striving to eliminate their need and their reflection and dependence on fossil fuels. So again, this is sort of an outline, talking again about the introduction, goals and objectives, resource use management. In other words, in terms of the project, what have they done to date? What are they projecting to do as far as any conservation measures or improvement measures? You know, what's their supply management, looking again at what utilities do they work with? What are those rate structures? They want to take a look at where they are as far as their baseline and benchmark, their financial analysis, roles and responsibilities, measures and results. Again, when you take a look at a strategic energy plan, like any other master plan, it's something that is a live document that needs to be updated on a regular basis. We pretty much recommend that every 3 years, or at least every 3 to 5 years, depending upon how active that particular group is, that they evaluate their energy plan and they update it as need be. And another way of looking at it is an energy roadmap. You know, you can almost interchange the terms. It's, again, a master plan that helps a facility in forecasting, prioritizing, and budgeting with respect to their equipment and systems. For example, we happen to have a client that's going to be bringing probably another 2 million square feet online within the next 2 to 3 years. And again, they need to take a look not only at the facilities in terms of maintaining those, but from a utility standpoint, from an operational demand standpoint, you know, what are they expecting in terms of utility bills, in terms of support and maintenance, and, you know, what are their policies and procedures? And again, looking at the security, this happens to be a client that needs to be online 24/7. Again, energy benchmarking analysis. You can see some of the things that feed into an energy roadmap. Again, a live document that gets updated on a periodic basis. So again, establishing an energy baseline, we'll talk a little bit about that. Now, what is a baseline? Well, again, you've got to take a look And what you're trying to do is establish where you are today. What is your current demand and consumption? What's the boundary that you're looking at? Are you looking at a specific building? Are you, for example, looking at a campus? Maybe you're a corporate entity, or you're a university and you've got a campus and you want to look in totality at all your buildings. Are you a company? Are you a management firm that has a portfolio of buildings? And what are you striving to do? What's your baseline year? You know, are you working on a calendar year, fiscal year? You're looking at it on an annual basis. What's your energy use data? What's your fuel source or sources? Electricity, gas, oil. What are you using? How is it being procured? Okay, and then calculating that energy use intensity. And we're going to look at that in a couple of minutes. What is that metric, and how do we calculate it, and why is it important? So energy use assessment, again, starting out, what we want to do is we want to get some historical data from utility bills, from maybe energy supplier bills, depending again on who your customer or client is, what their contracts might be, and again, tracking the data on a building by building basis, or again, whatever your parameter is. You can do that through sub-metering or power monitoring, which a lot of modern buildings have this basically installed on their panels, on their switchgear, etc. BAS trend logs for the building automation system, data loggers, being able not only to gather the historic data, but moving forward, being able to measure what's out there so that you can continue to track your progress. And then what you want to do is strike what we call an energy balance, a 4-part process whereby you first start out identifying the baseline energy used by the fuel source. And it may be a little hard to read here, but in the upper right-hand corner, you see there we've got by fuel source. Here's a particular facility where they've got electricity, district chilled water, and gas. And that's sort of the breakdown that's been identified, again, by some sort of invoicing, some sort of measurement that was captured. Then you want to define the energy balance for each energy source. So for example, if you took the electricity, you would want to break it down and say, okay, how much for HVAC system, how much for lighting, how much for plug loads, how much for data equipment. And then if you've got really large energy consuming systems within that source, you break it down further. For example, you kind of see here fans, chillers, chilled water pumps, heating water pumps. Again, trying to drill down, trying to refine, again, where that energy is being consumed, because that's going to allow you to target the greatest energy consuming systems and see what you can do in terms of energy efficiency and savings. And then finally, once you have all that data and you've established it, you create a baseline. It's a baseline against which your estimated energy consumption can be measured going forward. And that's really the key in establishing, your baseline. There's a lot of influences on energy consumption. I think everybody on the call probably is well aware. I mean, with respect to the envelope load, the climate, the weather, ambient conditions, they have a huge effect. The efficiency of the envelope, how well insulated is it? How tight is it with respect to air and water penetration? Seasonal activities can have an effect. For example, we know that in the retail market, there's a lot of traffic, there's a lot of activity around Christmas time. In the educational market, we know that for school systems and universities, they basically have a couple of semesters where children are in class, but then they also have vacations or breaks. Occupancy and occupants' behaviors, energy intense operations. You've got facilities where you've got data centers or manufacturing where there's a very intense level of energy consumption. And then finally, any kind of scheduling, when is it occupied, when is it not occupied, so on and so forth. Energy performance benchmarks. So we've used the term baseline. Now we're going to talk a little bit about benchmarks and what's the difference. Well, the baselining, as we just talked about, was comparing, a plant or a process or a building over time. relative to its measured performance in a specific baseline year. So once we've established that initial year, we can then use that as a baseline going forward to see how that particular facility or process performs over the next increment of time, typically on an annual basis. Benchmarking is comparing the performance to an average or best practice level against its peer group. So for example, if it's an office building, you may want to compare it to other office buildings that have a similar usage, similar type of occupancy in that same geographic area. So you can see how you're performing against some of your peers. So I used a term a little while ago, energy use intensity. It's also energy use index. They're basically interchangeable, but EUI is the acronym. And it's basically a measure of the energy consumed in kBTU within a building divided by its total square feet. So basically the annual building energy use on an annual basis, okay, divided by the building area in square feet creates your energy use index. And in terms of a BTU, again, a BTU is the heat required to basically heat 1 pound of water 1 degree Fahrenheit. So why are benchmarks important? Well, again, they're important because you would like to know how your building is compared to other similar types of buildings, but we're also seeing a real big increase now, particularly with a lot of municipalities, with required to commercial building owners being required to benchmark their building. A lot of them are using Energy Star's Portfolio Manager and then having to basically publicly disclose those results. You basically have to, share with, with the government and with your peers how your particular building, so that perhaps prospective tenants want to take a look and see, okay, how do these buildings match with respect to their efficiency, with respect to their performance. And so these disclosure laws are really driving a demand for benchmarking services, for retro commissioning, as well as, again, the implementation of many efficiency projects, okay? A lot of people, particularly the owners, want to improve their property's performance levels. It really enhances the value of their assets. So recently, EMA and Energy Star, we co-hosted a webinar, State and Local Energy Policies, again, looking at some of these various requirements that are out there today, trends in energy benchmarking and disclosure. That webinar is available. It's available at our website. You can see the link down below. It's available to watch. At the end, there's a short quiz. You pass the quiz, and it's eligible for a 1 CEU. So in terms of benchmarks, again, that we mentioned Energy Star, we mentioned Portfolio Manager. Again, this is all available out on the internet. But again, we talk about being able to compare against peers. So when you take a look here, this is a typical sheet that I've grabbed off of there. And you can see the broad category. On the far left, you can see, for example, healthcare. You can see primary function, where it's kind of refined a little bit, hospital, medical center, etc. And then further breakdown. Then you see two columns. One is called source EUI, again, kBTU per square foot, and the other site EUI, same thing, kBTU per square foot. And then the reference data source. We'll talk about source and site in a second, but again, where is this data coming from that establishes, again, these averages? And it really is coming from this, when you see CBECS, that acronym stands for Commercial Buildings Energy Consumption Survey. And this is a survey that's done periodically in the commercial marketplace, where they basically grab the data, they refine it, they basically vet it to make sure that it's accurate, and create and update these numbers. We go into more detail in the workshop on that. We don't have time today, but that gives you a little bit of an idea. The other performance benchmarking tool that's out there that we see a lot now, it's starting to gain traction, is ASHRAE's Building Energy Quotient. This is another energy rating program. It's got two separate workbooks, as you see here, as designed and in operation. It rests itself, as I mentioned here, on ASHRAE methodologies and standards. There's a little bit more what I would call credibility in this one. A lot of the information in Portfolio Manager can be input by the owner. It's perhaps, for their specific building, okay? And it's not always vetted. It's not always checked. In the BEQ process, it needs to be compiled and then basically uploaded by, as you can see there, either a PE licensed in that jurisdiction or, again, an ASHRAE professional, either energy modeling or energy assessment, BEMP or BEAP. We're working with a university right now that has mandated that all their buildings be assessed and benchmarked according to the BEQ program. And then they've also made a commitment that every 3 years they will retro commission every one of their buildings. So it'll be on a staggered list, but they intend to retro commission every building within a 3-year span. So source energy and site energy, I mentioned that a second ago, so let's talk a little bit about that. Site energy is what your utility meter would read, and that's actually the energy that's used on site. So for example, in the graphic that you see down below, you see the office building on the right-hand side, and the little orange arrow says, okay, whatever energy is consumed in that building, okay, that's what my site energy is, okay? And that's what that EUI is tied to. Source energy takes into account the loss for production and transmission. So it's really the raw energy entering the power plant. So you see the blue arrow at the bottom. It basically takes in that generation and that transmission and any loss associated with that for delivery to and then consumption by the building. So to give you an idea what the difference is, we'll talk about that. The table on the right here, source site ratios for all Portfolio Manager fuels. This is that ratio to convert from a site to a source. And you can see the various fuel types, and the ratio is really a multiplier. So for, again, purchasing electricity over the grid, the multiplier is 3.34. That's accommodating the generation and the transmission losses. Whereas if you were generating electricity on site, it's 1.0, okay? So the first problem we're going to talk about today is, again, a sample problem dealing with EUI. We've got an 80,000 square foot office building. It includes gas boilers for heating, has a demand response agreement with the local utility company to utilize its on-site generator during high demand periods. Its annual metered energy use by fuel is as follows, and you can see it there for electricity in kilowatt hours, in natural gas cubic feet, and then in diesel oil in gallons. So briefly, for those that may not be familiar, demand response agreement is when the local utility goes to a customer that has on-site generation, perhaps the bank of generators, for example, a large data center, a hospital, and they say, look, during periods of peak energy demand, electrical demand, if you will basically bring on your generators and then reduce your demand, reduce your consumption, in return for that, we will give you some sort of, basically some sort of allowance. We may either monetarily or in some sort of adjustment to your rate. So that's what a demand response agreement is. And for a lot of large clients, they're willing to do that. So what's the site EUI and the source EUI for that particular office building? Well, the site one of the things you have to do is, again, convert into kBTUs. Remember, we said EUI is measured in that. So we take the kilowatt hours per year for electricity by its conversion factor. Same with cubic feet of gas. Same with gallons of diesel fuel. We convert all that to kBTUs per year, add them together, divide by 80,000, and you can see that for this particular facility, the site EUI was 59.28. So how does that compare with the source EUI? Well, again, we go back to that table I showed you a couple slides back with the source site ratios. And now we take the data that we just had, that we calculated over here, the kBTU per year, and we take it times the multipliers that were from that table. So for electricity, I showed you that if you're purchasing off the grid, the multiplier was 3.34. So work through those multipliers, come up with the new totals, divide by 80,000, and the source EUI for that same building was 145.95. So, you know, one of the things I pointed out a second ago, if this particular client had sufficient roof area or maybe some adjacent land and they said, look, we're interested in doing a solar PV farm because we want to have some on-site generation, what effect would that have on the site EUI or on the source? Well, on the site EUI, assuming he's consuming the same amount, it's not going to have any effect. But on the source EUI, whatever percentage of electricity he's able to generate is less electricity that has to be purchased from the utility company or from the grid, so that number would decrease. The source EUI would decrease. Now, while EUI metrics, the common metric, as I just showed you, kBTU per square foot, there are clients, there's people out there that like to measure their, utility consumption, their energy according to other benchmarking goals, other metrics that they use. Any building can be on the kBTU or BTU per square foot. Some clients, some people want to measure, how much energy is being used or what their billing is against how many employees they have. An assembly plant may measure it against unit of product, or a manufacturer pound of product. If you have a hotel or a hospital, they may measure it against the number of occupied beds. And then finally, and everybody's pretty familiar with this, the kilowatt hours per square foot is a common metric when you're looking at lighting. Next, we're going to talk a little bit about utility invoices. And again, this is very important for energy managers, energy management professionals. And start out a little bit about terminology. So kilowatt hours, the amount of electrical energy that's used over time. So that's basically your consumption. How much energy are you using? Demand is the amount that you're pulling or demanding at any period in time. Power factor is, basically power factor is a ratio. It's basically the real power that's absorbed by the load over the apparent power that's flowing in the circuit. And, we're not going to get into electrical engineering here, but in essence, it's talking about how efficiently or effectively that customer is using its power. And if you have a low power factor, which means it's very inefficient, you may be penalized and face an additional charge from the utility company. And there's various ways you can correct your power factor. Distributed generation, you're talking again about on-site generation or some sort of district or decentralized energy, that's generated and stored and then fed in as you need to. Flat rate structure. So again, there's multiple ways that utility companies or energy companies will charge customers for their energy. Flat rate is merely a fixed cost. In other words, the only exception to that is maybe an adjustment for fuel cost or other taxes and fees. But you're paying X cents per kilowatt hour, and, X dollars per kW of demand. Seasonal flat rates are available in areas where you've got a larger demand during one season or the other. Maybe it's in the summer or in the winter. And so basically those rates adjust by the season, typically on a month-by-month basis. Time of use rates adjust by the time that you use. It could be a daily rate. There could be certain number of hours each day that they deem to be on peak or off peak. And during that time, the rate will change, the rate that you pay. And that tiered energy is basically now almost a step. There are utilities out there that will charge X number of cents per kilowatt hour up to a certain threshold. Once you break that threshold, some of them will reduce the cost per kilowatt hour. Others will increase it. It could go either way depending upon the utility. But that's more of a step thing. Utility rate structures, again, most of your utility bills are divided into three pieces: customer charges, recovering the costs associated with making the service available, demand charges, again, and you can see there, capital and operating costs for production, and then supply charges. So when you take a look at a bill, a lot of times when you start analyzing it, you have to take a look and see what you're being charged, and you have to analyze that against the rate structure. And again, that's an important aspect of an energy management professional. Again, auditing utility invoices. So again, the meter accuracy and then evaluating the invoice. When was the meter last calibrated or checked? When did somebody actually evaluate or verify a bill against what was perceived to be the rate schedule that they were being charged? I would point out the second bullet here. The National Utilities Refund is an organization that helps individuals with auditing their utility bills. And they say on average, 80% of the companies that they evaluate are overcharged on their utility expenses through either calculation errors or discrepancies billed by the utility providers. That's why it's really important, and one of the important, like I say, jobs up front is to really audit and evaluate the invoices that your customers are paying. Real-time utility account access, you can coordinate with your utility company to perhaps get real-time access to how much is being, what your demand is, what your consumption is. Sub-metering is really important if you're trying to identify your large energy consuming loads and track them. Electric meter location, we don't see this as great of a problem, but as I say here, if the meter from the power company is located on the line side of the service, that the charge may be 3 to 5% higher due to losses in the transformer. The way that data is presented is really important, particularly for perhaps people in the C-suite, the corporate suite, that are less technical. And graphically presenting data is so important, particularly when you're looking at different profiles like this. I just present this as a quick, exercise. When you take a look, all the data that's shown and represented up here on the graph in the various colors is really in the table down below. And if somebody looked hard, they would see that there's certain numbers that are larger than others, and whether or not they would jump out as much, I would be kind of suspicious of that. But when you graph it like they've done here, this is a couple of hospitals and medical centers, and obviously you see a tremendous jump during March for GCMC. You see this tremendous jump. Why did that occur? What was the problem? This is where, if you've got the available data, you can go back, you can talk to them and say, what was this an error? Was this an error in the billing? Was there something that happened that occurred during that month in your particular facility that would cause this anomaly? That's one of the things you need to take a look at. So now we'll move to another sample problem. We'll talk a little bit about utility invoice audits. And again, being able to do, these are very simple calculations, but again, taking a look at the difference between these charges. So here we have really the annual data. We've got electrical consumption, electrical demand, and natural gas for basically a 12-month period for this facility. And you can see the kilowatt hours, kW, and the cubic feet of gas. You can see the totals at the bottom. The consumption charge is 7.4 cents per kilowatt hour. Transmission and distribution, often the acronym T&D, is 8.3 cents per kilowatt hour. And the demand charge is $5 per kilowatt. So what are the demand charges for August? Okay. What's the total electrical cost for August? And what is the blended electrical energy rate? Now, we haven't used that term yet, but blended electrical energy rate is basically taking all of the costs associated with, with that particular utility, with that particular energy or fuel source, and basically adding them together to get what we call a weighted or blended energy rate for the year. So we take a look. August, we had 900,000 kilowatt hours. We had 20,000 kW of demand. So the demand charges in August, pretty straightforward. 20,000 times $5 a kW is $100,000. The total electrical cost, 900,000 kilowatt hours times 7.4 cents, 66,600. Demand, we know already from above, 100,000. And then we have that transmission and distribution, 900,000 at 0.083, 74.7, add the three together. The total electrical cost for August was $241,300. Now, talking about the blended electrical rate. Now we want to look on an annual basis to take a look, and we go back for a second. We take a look at the totals at the bottom. We got 7,149,000 here in kilowatt hours. We have 198,000 in demand. So we take those numbers, consumption, 7.4, 198.3 times 5. Again, transmission distribution, the total consumption, times 8.3. Add those three together, the total cost is 2,114,034. Divide that by the total consumption, 7,149,900 kilowatt hours, and we get a blended electrical rate of 0.296. Again, a lot of engineers, energy managers will use a blended rate when they're doing their calculations. When we do our workshop, we talk about the pros and cons of doing that, of using a blended rate, and the accuracy of that versus basically trying to drill down to see what effect and a specific measure might have on demand versus what effect it'll have on consumption. But again, the use of a blended rate is fairly common in the industry. Now we'll talk a little bit about energy auditing. For those that have been in the industry for a while, you probably remember the old green covered book that ASHRAE put out for a long time. That particular book was their guidelines for commercial building energy audits. There was never a standard, okay? It was a guideline. It talked about the three levels, level 1, level 2, level 3. ASHRAE started work several years ago. They basically have now adopted Standard 211 2018, the standard for commercial building energy audits. Briefly, the difference, for those of you that aren't familiar with ASHRAE, the difference between a standard and a guideline, ASHRAE will write a standard in what they call codified language. Codified language means it's written in language that can be easily adopted by codes, so that the intent of a standard is that if code authorities want to adopt it, it can be adopted fairly readily. But I want to point out a couple things here in this standard. This is the first time the standard has really talked to, in this standard, energy auditor qualifications. They talk about who is qualified to do energy auditing. And one of the things they say is it's somebody that is basically certified through an ANSI accredited program that's recognized by the Department of Energy, Better Buildings Workforce Guidelines. And the Energy Management Association's Energy Management Professional, EMP, complies. We are accredited by ANSI. We've been recognized by DOE. So for individuals that carry that certification, you would be qualified to do energy auditing under this standard. It provides specific guidance on quality control. It's more customer oriented. It does reference ASHRAE Standard 100. ASHRAE Standard 100, it happens to be 2018 now, is the energy efficiency in existing buildings. And that particular standard has a number of appendices, one of which has a long list of recommended measures to be considered when you're auditing and when you're evaluating an existing building. It also talks and provides a little bit of guidance for building energy model calibration. It defines the procedures. It still reverts back to and divides the procedures for levels 1, 2, and 3 energy audits. And basically it does that to provide a common scope of work for those audit levels so that if there's a building owner or client out there that's asking a consultant to provide or perform an energy audit, he can basically reference this standard and basically define what level he's seeking for that particular deliverable. Again, the idea was to establish standardized industry practices. So the way that it's set up is they have level 1 is again up what they call a preliminary energy audit. Level 2 is standard. That would be your, if somebody just said energy audit, you would expect that they're defining a level 2. And then level 3 is more detailed. That's an investment grade audit. That's the type of audit you would typically see required in a ESCO, an energy service contractors, particularly for performance contracting. So basically they build upon themselves. And that's the way that the standard is written, okay? One of the things you need to do is define the scope up front with your client. Does he want you to look at all the energy consuming systems within the building? Does he want you to look at any of the process systems in the building? Does he want you to look at the building envelope? You need to define that scope, and then you need to define the level of effort. And again, an energy audit is different from a facility condition assessment. I mean, they may be some overlap, but really consider a facility condition assessment to be more of a multidiscipline review of the assets and systems within a building. You know, and you're really trying to evaluate the life expectancy and any kind of reinvestment cost. You're basically looking at the physical needs of the building, the capital needs of the building, and maybe even the functional needs. But an energy audit, facility condition assessment, a lot of people may call them the same thing, but they really are different. So again, the way that the standard's written, level 1 procedures, and I've basically listed them by bullets here, are defined in the standard. And then what they do is level 2 says all the level 1 procedures and these additional ones. And then level 2 says, or level 3 says all the level 1 and level 2 procedures plus these additional. So briefly, again, reviewing the historical data, utility rate structure, some of the things we've already talked about, performing a site assessment and survey, identifying any O&M problems and needs, which is why it's really important to interface and work closely with the facility staff at that particular facility. Identify, again, the critical energy using systems and processes, interview the key stakeholders, and those key stakeholders could be from management, they could be the facility operators, and they could even be tenants, occupants in the building. As you walk through, you may want to identify the space function analysis to see if it's changed from what the building originally was designed for. What are the key operating parameters? And then again, in level 1, you're really looking and focusing on low cost, no cost energy conservation measures. What could be done fairly readily that's going to have a return on investment, for your client. And then at the same time, you may identify larger capital measures that would require further analysis, but they would not necessarily be analyzed under level 1. Level 2 procedures, again, as I said, they follow everything in level 1, plus you really now want to get into that energy breakdown, that energy cost breakdown, that what we talked about, that energy balance, basically refining and dividing where is your energy being used by fuel source, by system, and so on and so forth. What are the O&M procedures? And then how is it being operated? What are the set points and schedules? And then again, refining and going in more detail. And then here, as you identify measures for a potential energy savings, you're going to do a greater effort in terms of calculating those savings and then calculating the cost involved in implementing those, and then what's the return on investment, what's the payback. Same thing, if there's interactive measures, now what are interactive measures? Again, briefly, that if you had 2 particular measures, one, for example, was impacting the envelope, for example, you're going to add roof insulation, you're going to change out the windows. And in performing that measure, you're going to reduce the load on the building. Well, then if you're also looking at changing out some of the central equipment, chillers, boilers, or whatever, you've got to understand that if you reduce the load, then you're not going to have the same savings you would have had if you had just simply replaced it with a building of the same envelope. Calculate the energy savings, again, estimate the cost, and then conduct what we call the economic analysis. And then level 3, again, as I said, everything under level 1 and 2, additional analysis on all the EEMs that meet the owner's criteria. Now they really want to see a diagram of the new equipment where it's appropriate, or the new control schemes. You want to conduct the analysis using more refined data, measured data. You want to do energy modeling or more sophisticated calculations. You want to do a better job at estimating the cost. You may employ contractors or vendors to get specific pricing. And then again, what's the impact on any seasonal requirements for the building and its occupants? Initial and recurring cost. And again, the analysis on the economic side tends to increase as you go from level 1, which oftentimes is simple payback, to level 2, which is oftentimes some sort of a present worth analysis, to level 3, which is oftentimes a life cycle cost analysis. And we'll talk a little bit about those in just a second. And then finally, a risk analysis with respect to the project. So now again, we've kind of walked through the audit process. Now we want to talk about, we've identified some energy conservation measures or FIMs, or we're in the process of identifying those. So where do we go? First of all, a little bit about terminology. We throw around the acronyms ECM, EEM, and FIM. So again, this is kind of the definition. Energy conservation measure or energy efficiency measure is really a measure that has been identified as helping to reduce the consumption of energy in the building, and or any utility. It may be water, maybe electricity or gas, whatever. Facility improvement measure is really looking to improve the building or system performance, but it may have, a greater effect on reliability or resiliency, reduce O&M cost, improve indoor environmental quality. The measure may or may not reduce energy consumption. Actually, we see these interchanged a lot, and some companies such as ourselves have really adopted one term, which is facility improvement measure. That I think is a great term. Whether or not the measure saves energy, again, to basically define all of them under one grouping and then to prioritize them and rank them depending on what your priorities are, and we'll talk about that in a second, is I think better than trying to divide them into two groupings, ECMs and FIMs. So again, as you're walking the building, and we talk about this, or as you're doing your analysis, we like to do an initial screening and basically assessing those energy conservation measures or FIMs, whatever. As you walk through the building, you can have a checklist with you. We've developed a multi-page checklist that's divided out by discipline, whether it's equipment, controls, etc., so that the individual in the facility, as he walks through, can basically make a quick determination. This is something we want to look at or not. It's not going to be applicable on the project. And then when he gets back, he can do further analysis. It also helps you as kind of a tickler to make sure that you don't miss anything, and you discuss potential measures with the facility staff. Again, a lot of this is based on experience from individuals that understand mechanical electrical building systems and have been involved in audits previously. Again, being able to identify the potential measures and then go back and do further investigation to either vet them as being worthy of further analysis or being dismissed as not being viable. And again, it depends upon the scope that we talked about a few slides back. What was your scope of your project? I mean, were you looking at all of the energy savings? Is it controls, HVAC, lighting, water envelope, or were you restricted in your particular scope to just the HVAC systems and controls? Again, that's something that you work out when you define your scope of work with your owner or client. Again, evaluating energy opportunities. Again, establishing that savings methodology, like proposed change or modification, unit energy cost. As I said a little while ago, it may be a blended rate. Again, there's nothing wrong with using those, particularly for initial analysis, to accommodate, again, the consumption demand and any other charges. If you get more sophisticated, you probably want to divide it and do an analysis both on consumption and demand. Cost estimating procedures, again, cost data guides are out there. If you have a good relationship with contractors or vendors, internal costing for in-house implementation, it's possible that either your company or maybe the client you're working for has the ability to do some of the costing. But again, the calculation of savings and the calculation of costs are really important. And as I said earlier, it kind of gets refined as you go from level 1 to level 2 to level 3 in terms of detail. So now we'll jump on our next sample problem here. Again, these are the problems I've presented today are fairly simple problems. They get the workshop goes into a lot more detail and more sophisticated, but I wanted to just give you a little bit of a flavor through the various sections that we're dealing with today. So for example, in this one, during an energy audit, it's discovered that a laboratory has 3 exhaust fans that are serving fume hoods, and they're currently operating continuously, 24 hours a day, 365 days a year. In the discussion with the users of the building, it was determined that the fans only need to operate from 8 to 5 for 5 days a week. Each fan motor is a 0.5 horsepower single phase with a power factor of 0.85. The nameplate on the motor lists 4.9 amps at 230 volts. The blended electricity rate is 7 cents per kilowatt hour. By reducing the runtime on the fans, what is the approximate savings per year? Okay, let's take a look. So each fan, we've got 3 fans, 0.85 power factor times the voltage times the amps is 958 watts. So we want to convert that to kilowatts. We've got a savings during the week, 15 hours a day that they can be off, 5 days a week for 52 weeks a year, saves us 3,736 kilowatt hours. Plus, we've got 2 additional days on the weekend. So 24 hours a day, 2 days a week, saves us an additional 2,391 kilowatt hours. The total is 6,127, 7 cents a kilowatt hour. The savings per fan is $428.92. Take that savings times 3, because you have 3 fans, and the total savings is $1,286.76. So what's the implementation cost? It's really nothing. You're just turning the fans off. Okay, economic analysis. I've talked a little bit about that. We'll talk again briefly. Again, I know I'm going through a lot of different, but I want to give you a flavor for what we talk about in the workshop. And again, we have the opportunity in a day and a half to go through a lot more detail. So evaluating energy opportunities, establishing the financial analysis method. And as I said before, you know, for really preliminary energy audits, you could do simple payback, and the return on investment is really just the inverse of simple payback. The payback in years is the initial cost divided by the savings. Return on investment is, again, the savings or return from investment on an annual basis divided by the cost. And then we'll talk briefly about present worth analysis and life cycle cost analysis. So we'll do a problem on payback and return on investment. Again, it's very simple, but an energy management professional identifies 3, actually it was 4 ECMs, I'm sorry, with the following estimated cost and projected annual savings. So here's the 4 ECMs. There's their cost. There's their savings. The owner decides to implement all 4 of the measures. What is the simple payback for the project? What is the projected ROI for the project? Simple payback, again, you add up, you know, going back for a second, you basically add up the cost and you divide it by the savings. 24/2, 6,500, 3.72 years. The return on investment on an annual basis, just the inverse, 6,500 divided by 24,200 is 26.85%. It's 0.2685, which is 26.85% annual return on investment. So again, simple payback is for preliminary analysis, you know, particularly if you're trying to evaluate whether or not a measure is worthy of further consideration, is fine. But as you get more detailed, you may want to advance into what we call net present worth analysis or net present worth value. So again, these are kind of the pros and cons. Payback, as you can see, it's simple to use, easy to compute. It is preference for liquidity, but it ignores the time value of money, and not all cash flows are covered. So net present worth, it's more flexible and meaningful. It does accommodate costs and savings over the life of the project. So it's a preferred way of doing an analysis. Here's basically the formulas that you use, where I is the annual interest rate, N is a period of analysis. This is very rudimentary, but and it can get a little bit more complicated with that if you've got various costs that you're analyzing over a period of years for example, O&M cost, operating cost, so on and so forth. But basically, you work with this. So, life cycle cost analysis. So, as I mentioned a second ago, as you step up, okay, and when you get to what we call level 3, basically you're looking at life cycle cost analysis, a much more sophisticated, where you're assessing the total cost of the facility ownership. You want to take into account all the cost, acquiring, owning, disposing of the system. And this gives you an idea down below of all the various costs that would go into this, that would be involved. And without getting extremely detailed, but trying to reflect it in what I would call a very simple linear equation, and you still have to pull it back to present value, the total life cycle cost is basically the initial investment cost plus the replacement minus any kind of residual value, which could be salvage value, etc., plus the energy cost, any kind of water costs that may be involved, O&M, or repair cost, and then finally any other cost. There may be other costs, like for contracts, if you're associated with an ESPC, energy saving performance contract. So basically, there's a lot more to it, but these are the types of analysis that are required if you're considering entering into an energy services contract with a performance guarantee. So beyond cost and savings, there may be other factors to consider, and those factors are listed here: regulatory or code compliance, life safety issues, maybe efforts to meet a green certification or sustainable certification like LEED or Green Globes. You may be striving to basically improve employee comfort or indoor environmental quality, or to increase the productivity. So there could be other factors that have to be considered as you evaluate energy conservation or energy efficiency measures as you go forward. So implementing energy measures. So once the analysis is done, and if it's a large facility, and we happen to have a client that had multiple facilities, and he had a number of energy audits that he had solicited and obtained for his facilities over a period of time, you have to have a methodology, and it really comes from discussion with the owner on how you're going to rank those measures for implementation. And it may be a weighted average. We'll talk about that in a second. But for example, are you looking at those with the shortest payback or return on investment? In other words, what measures offer the most bang for the buck? You may be looking at measures that have the largest potential savings, which could have the largest impact in terms of reduction in energy use. You may be interested in measures that have the lowest implementation cost. You have a limited budget. Which are the least expensive to implement? You may have a goal to, like we have with one of our clients who wants to decrease the average EUI of his whole portfolio by 10% within 3 years. So, where can an ECM have the most impact relative to the current energy usage of the building? What's the potential reduction in EUI? What's a deviation from buildings of similar use? Which building has the energy use currently furthest above the others of its type and size? In other words, which is your worst performing building, and you want to prioritize measures for that building to bring it back in line. Or, those 5 I've just talked about, maybe it's a weighted average. You want to put a certain weighting on that ranking. What we've done before is we've taken a list of measures, we've ranked them according to these, these various priorities here, and then we talked to the client, and then we put weights on them, and then basically created what we called the final prioritized ranking from that. And as I said a little while ago, beyond energy, there may be other intangible benefits, that you may be looking for. For example, increase the lighting with a more efficient source, particularly exterior lighting or outdoor lighting for safety and security. Preparation for sale. Again, we talked about the fact with a lot of these municipalities that have these ordinances now that require the owners to disclose the performance of their buildings. Again, they may be saying, what can I do to improve my performance, in terms of EUI, because I'm looking to market my building within the next several years. Sustainability initiatives. You may have a case where you've got a client that for whatever reason, wants to pursue LEED or Green Globe certification, perhaps LEED E-Bomb, existing buildings O&M, to demonstrate to corporate, to demonstrate to the community, that, he's a good steward of the resources. Code or ordinance compliances. And again, what I said a little while ago, some of these municipalities have actually enacted, like New York, requirements for retro-commissioning of all commercial buildings above a threshold size on a 3-year basis. The final criteria has to basically involve everything. You've got to look at the owner's goals and objectives. You've got to look at prioritizing according to cost and budget, any mandates, any other benefits. So again, this is where your relationship with the owner is very important, and being able to identify and recognize his goals and what he's trying to achieve and help work with him to prioritize the measures that he's going to implement. Now, there's a lot of energy managers or energy management professionals that, will be carried forward through project implementation. You may be working with a project manager on their staff, the facility management group, or they may even engage you to basically manage the implementation. So again, who's the responsible party and what are their roles? Who's going to be responsible for ensuring the performance of the system? Create a program or what the objectives and requirements are. What's the type or detail of documentation required? Again, depending on what the measure is, if we talked earlier with that sample or problem that we did, which was basically turning off the fans, there's a lot of measures that may deal with controls, schedules, set points, sequences of operation, where basically you can make that adjustment. You can basically create and issue a narrative or a narrative in a sketch. Perhaps you're relaying out the lights because a particular area is overlit, and you can basically reconfigure the lighting to reduce the lighting levels, and it's not going to require detailed drawings or specs that have to go forward for permitting. Coordinate access requirements for the contractors. Again, if it's an existing building, are there going to be any restrictions on when they can work? And again, what's the project budget? If it's an existing building, we strongly recommend that a contingency be included because there may be unknowns. What's the schedule and what are the milestones? And as I said a second ago, phasing requirements, are there any limits to when the contractor can work during normal hours? It depends on what it is. Once again, if there's a lot of control adjustments, those can be done back of house, and it's not going to really affect the people out in the work areas. Determine the procurement or delivery method. Once again, how is the project going to be implemented? How's it going to be delivered? Does the owner have in-house staff or on-call contractors that can perform the work. If not, is he looking to engage a construction manager? Is he looking to have the project done design build? Or in some cases, is he looking to engage a energy saving performance contractor and get a performance guarantee? Again, these are all things that you can work with. If you're an energy management professional, you would work with your client and make recommendations and considerations in all this. One of the things that's important is, again, the documentation and training, so that as you go through, you've done your auditing, you've done and implemented the project, you've made adjustments to the building systems. Okay, where we go with respect to documentation and training of the O&M staff. Well, it's really important to have accurate as-built information. Detailed documentation of all the modifications that were implemented, detailed documentation of all the control system modifications. This is really important, again, in the future, so that the O&M staff, the facility staff, has that information available to them. Current facility requirements. Now, this is another requirement. A CFR, it's now required under LEED version 4 to be developed. It's also required under ASHRAE 0.2 for existing building commissioning. We'll talk a little bit about that, but a CFR for an existing building is similar to an OPR, Owner's Project Requirements, for a new building. An OPR is created at the onset, with the program as to what the owner's trying to achieve in developing a new facility. The CFR really is what is developed at the end of that project when the building or facility is brought online, and it's also required for a building that perhaps has never had one, so that you can really document at that point in time what are the user and occupants requirements, what is the owner directed. You kind of see the contents down below there, and it crosses a lot of various areas, like you say, environmental and energy goals. What are you trying to achieve? And then going forward, training and sustainability requirements, and then also equipment and systems maintainability. You can see everything here, and then ongoing commissioning. So the idea is that you're creating a document that, again, is somewhat of a roadmap for that particular facility going forward. And then if there's any future modifications, renovations, or adjustments to the use or occupancy of that facility, they would take the CFR and update it just like you update an OPR during the course of a new construction project. Now, another document that's really important is a systems manual. And I list here guideline 1.4 2014. I recognize now we're going to update that. There's a new one that was approved in January. It's 1.4 2019, and they've changed the title slightly, and now it's just preparing system manuals for facilities. So they've not only updated the guideline, they changed its title, and we'll update that before we send out this slide deck. But in essence, the guideline is, follows what you see here. And a systems manual, unlike an O&M manual typically focuses on individual pieces of equipment and how you operate and maintain those particular pieces. Whereas a systems manual looks at system level information. It's looking more on a system basis, such as an air handling system, a chilled water system, and basically more from an integrated standpoint. And as you can see here, the components include that system configuration, the operational data, maintenance data, troubleshooting, and so forth. That's another piece of documentation that it's really critical to compile and have as a deliverable. O&M manual, again, there's another ASHRAE guideline for that. It's guideline 4, preparation of O&M documentation for building systems. I've listed here in these bullets what some of the requirements are that are outlined that need to be included within an O&M manual. Again, if an existing facility had an O&M manual and now you've updated, maybe replaced some equipment, made some adjustments, you've got to look at making those adjustments and updates and edits to the existing O&M manual. Training, Guideline 1.3, 2018, Building Operations and Maintenance Training for HVAC and Refrigeration Commissioning Process. So again, here's another guideline for, again, how to develop training plans and conduct them. It's very important that if you've done updates, because this is part of your persistence of savings, that the facility group is trained on how to maintain this system and how to operate this system going forward. So now, once you've implemented whatever measures were selected by your owner or client, you want to ensure that they're going to perform as you expected, as you intended, okay? And that's where this persistence of savings comes in. And one of the first steps is to develop a measurement and verification plan. So there's really two key documents that are out there that relate to M&V. One is Guideline 14 for measurement of energy demand and water savings. The other one is the IP MVP. You can see there volumes 1 through 3, the International Performance Protocol. And a lot of those plans consist of, there's really two main options that are utilized for verification: calibrated simulation, or option B, energy conservation measure isolation. We don't have time to go into these in detail today, but what I would tell you is, again, I show you a link at the bottom. I've got a presentation, an hour presentation on M&V that I gave to NIBS back in January of this year. It's available on the website at energymanagement.org, and I would invite people that are interested in it to go out there. I go into more detail about the various options and give you examples of each one and talk further about the importance of measurement and verification. So again, the reporting strategy, you got to consider the metrics. You know, what are you measuring it against? Specificity, okay? Format, again, graphs are very important whenever you can. It really is critical that someone is tasked, and oftentimes it is the energy management professional, with this measurement and verification process. And it really needs to go on for at least that first year after implementation, and then we would recommend what we call continuous monitoring, which goes on a regular basis, you know, perhaps on a monthly basis, so that you're tracking, again, the performance of your various systems. Existing building retro commissioning, again, there's a guideline for that. I mentioned it a couple minutes ago, 0.2 2015. They really expanded retro commissioning or existing building from the 4-phase process it used to be into a 6-phase process. It goes from planning through what they call now ongoing commissioning. Again, there is a requirement, as I mentioned, for the current facility requirement, CFR. The final existing building commissioning report involves really over time through the implementation and handoff. So really, this could be a protracted process, particularly if you go through implementation of some of the measures that are brought up. And then the ongoing commissioning plan can be updated periodically. Now, again, what's so important about ongoing commissioning? Well, again, in spite of the initial commissioning and the M&V, performance will degrade over time. It is just a nature of rotating equipment and systems, and again, drift in control calibration, that systems will degrade and their performance will deteriorate over time. So it really is important to monitor and make those adjustments on an ongoing basis to prevent that degradation. An ongoing commissioning program can be depending on the sophistication of the facility, could be, fairly simple, or it could be, again, very complex. It can involve monitoring-based commissioning, a very sophisticated software package that performs fault detection and diagnostics. It depends upon what level you want to do. Again, we get into this in much more detail in the workshop. So again, planning, point monitoring, system testing, these are all part of the program. It establishes what the measurement requirements are, what points are to be tracked, and then what are the limits of acceptable values. And again, that's why if you use a sophisticated monitoring-based commissioning program where you can actually program in through algorithms what the acceptable range is, it will alert you if anything falls outside of that range. It also defines the review process to evaluate performance, action plan for identifying, correcting operational errors, and you can at least see what's the frequency of analysis. We would recommend at least quarterly for the first year, and then again, depends on the cycle, how often you need to review that program. Continuous monitoring requirements, you need to list the equipment, the data points, what the baselines are, calibration schedule. How often are you going to calibrate your meters or sub-meters and check their accuracy? And then, how are you going to track the EUI? Who's responsible for that? Again, if you've got this data available, there has to be somebody within the facilities group or again, yourself, if you're the facility management professional that's been engaged to do this work, that tracks this stuff and alerts somebody if it's out of tolerance, if you're outside the prescribed range. So with that, I want to talk a little bit briefly, again, about the Energy Management Association. We were created in 2012 by the AABC Commissioning Group, so we really are sister organizations with ACG. We developed what we call the Energy Management Professional Certification Program, which we see as a commissioning-based approach to energy management. We became an independent subsidiary in 2014. So again, we're sister organizations, but we're totally independent of one another. As I mentioned earlier, one of the things that's really important is that we received accreditation from ANSI for that Energy Management Professional Certification in 2018. And then immediately after, we're recognized by the DOE Better Buildings Workforce Guidelines. So we do have a certification, and we've mentioned before that there's going to be more and more organizations, RFPs, RFQs that are issued by institutions, by corporations, by government entities that are going to require certified individuals. And when I mean certified, I mean through accredited programs to perform their energy management tasks, whether it's auditing or anything else like we've talked about today, developing master plans, etc. EMA really, with ACG, really sees a synergy between commissioning and energy management. This is something that we've strived for a long time. Both of the processes are very focused and methodical. They involve investigation, testing, problem solving. Individuals that are commissioning specialists or EMPs need to have experience with a wide variety of building systems, understand their operation and optimization. They have to have a strong knowledge of building management systems and control sequences. They have to have a very good troubleshooting, investigative assessment skill. And then, as I mentioned, be able to write and execute functional testing and monitoring. And then also, in many cases, be able to work closely in the fields of sustainability and resiliency. Again, the Better Building Workforce Guidelines were developed several years ago. ACG and EMA had individuals on those committees that worked with the National Renewable Energy Lab, and with NIBS to help create those, what we call job task analysis in those responsibilities. And they define a building energy manager as responsible for managing, continually improving energy performance in commercial buildings by establishing and maintaining an energy program management system that supports the mission and goals of the organization. That's really their definition of an energy manager. This document is available online. You can take a look at it, and really has become the document. When we developed our program, when we developed our exam, we had to work around this and through this because we have to really adhere to the task analysis that was developed by DOE. That's how we got our acknowledgement and our approval. So with that, I want to, again, put a plug in for technical certifications. Why are technical, we talk about licenses. Architects are licensed, professional engineers are licensed, but technical certifications such as the EMP, the CXA, commissioning authority that's offered by ACG. Well, number one, it demonstrates commitment. It's a commitment by both the corporate and the individual to the client that they've taken the time and effort to become certified and to demonstrate the expertise in that particular area. It's recognized proficiency. We really believe that it's an important step in professional development. Again, as you proceed down that path, there's going to be a requirement under that certification, under most certifications, just as under most licenses today, that CEU and PDH, continuing education units, professional development hours, there's a requirement for those to maintain your EMP, but we provide a lot of webinars. We provide a lot of opportunities. We co-sponsor CX Energy every single year. CX Energy 2020 is coming up next April. It'll be out in San Diego. RFQ requirements, as I said a second ago, there's more RFQs and RFPs that are going to include certification requirements for the respondents. More codes and standards are defining the qualifications required to perform specific activities. And then government initiatives. There's more government contracts that will require individuals to meet those requirements. So a couple things I would invite, if you're interested in the EMP seminar and exam, we are offering one in Orlando in November on the 12th and 13th. It's in conjunction with the NFMT show down in Orlando. You would have to, get your application in. Again, we review it. We basically vet that you're, you've got the required qualifications. All the information for this is online at our website. The next opportunity after that is April 6th and 7th of 2020 in San Diego. We will again be offering the seminar and exam at CX Energy 2020. It is not a requirement that you take the seminar or the workshop. If you're qualified and you want to take the exam, you can take the exam. It's available at various testing facilities around the country. It is not required that you take the workshop, but if you want to take the workshop, it's a great refresher. As I mentioned earlier, one of the things that we've added over the last several years is a real focus on problems. And as I mentioned earlier, we actually send the candidates a group of 50 problems 2 weeks before we do the seminar, and then the answer key about a week before. We review all those, as well as we do additional problems during the course of the day and a half. We really feel that it's important that energy management professionals have that capability of doing the calculations, doing the analysis that's needed, for their clients and for their customers. And a lot of this has come from feedback that we've received from previous EMPs that have gone through the course and have gone through the process. They basically told us focus more and more on the calculations and the analysis, and that's really what we've done. So with that, we really are wrapping up. We really appreciate your attendance today. Once again, I'd like to send a thank you to Point Guard. Thank them for being the sponsor today for this training event. I hope everybody enjoyed it. The slide deck will be available and will be sent out within another day or so, and everybody will have an opportunity to take a look at it, review it. Again, thank you very much. Appreciate your time today, and hope everybody has a great day. Thank you.